Okay, so hello everyone, welcome. Can you hear me? Okay, can you hear me?
Yes, sir, we can hear you.
Okay, thank you. Okay. So now we'll start our today's session. So basically today I will try to discuss about that machine learning method in Google Earth Engine, and also try to show you that different types of implementation of machine learning method in Google Earth Engine platform. Okay, and also make the land cover classification map, as well as also check how we can easily check the accuracy, how we can easily calculate it, the area. So a lot of things we try to complete step by step. So let's go. So I simply share my screen. Okay, so now can you see my screen? Visible?
Yes.
Okay, thank you. Okay. So first of all, machine learning or ML is a powerful technique for analyzing the art observation data, and we can easily use the art engine has some built-in function such as different types of machine learning algorithm we can get, such as built-in capabilities to allow users to build the machine learning model and make the different types of classification or regression analysis. Okay, and totally it's the built-in model. We can easily find out this type of function, built-in functions such as support vector machine, then classification regression trace, then also about that minimum distance. Okay, so this type of built-in function has already in Google Earth Engine platform. Just we can use this and use the machine learning model for different types of work. So mainly in Google Earth Engine platform, we can do for the supervised classification, as well also do for the unsupervised classification and regression. Okay, so mainly supervised classification, mainly in this when you want to make the supervised classification, first of all we have to need some ground truth example, or we need to make the training data about that, and then we need to use the data as a ground truth or categorized data. So this type of data we need to use and then make the supervised classification. Okay, as well as also unsupervised classification model is also available in Google Earth Engine platform for the classification. So mainly when you want to do the unsupervised classification, then you don't need to take any types of ground truth data, or you don't need to make any types of training data set. You don't need to create about that. Okay, just it the algorithm is the clustering and similarities of pixel value, or similarities of the pixel value is the, and make the classification about that. Okay, and regression, so mainly in regression model, so mainly it work for the different types of predict water quality percent, forest cover, okay, present cloud cover to crop yield. Okay, so this type of analysis we are using here the linear regression. Okay, so in this time I will not showing the regression model about that, so it's our another advanced online training program, but I will discuss in this time and also show you the practical example for the supervised classification as well as also unsupervised classification. Okay, so these two things in machine learning algorithm how we can easily use and then make the classification. Okay, supervised and unsupervised. Supervised is that when you want to use the supervised, you must be need that ground truth data, or also take the make the training data set. Okay, and when you want to work for the unsupervised classification, you don't need to take any types of ground truth data, or need to make the any pre-categorized data. You don't need to make, just we can use here the clustering and make the classification about that. Okay, so first of all I try to discuss about the supervised classification. So let's go. So basically today I also try to discuss about that land cover classification, how we can easily do using the supervised and unsupervised classification. After that, how we can easily check the accuracy assessment of this map, as well as how we can easily calculate the area. Okay, then how to add the legend. Okay, so let's go. So mainly when you want to make the supervised classification for any classification, suppose you want to make the crop classification or normal, you want to make the for that normal classification such as build of area vegetation or any classification, when you want to apply the supervised machine learning method, you just follow some process or step, and this step is the same when you want to make any types of classification using supervised machine learning. Okay, so first of all, you have to selecting your ROI. Okay, this is the first step. You will just simply select your ROI or region of interest, which area you want to make the supervised classification map. Just import this area as the shapefile in Google Earth Engine platform. Okay, after that, you just simply choose and filtering your image collection. If you want, you can use the Landsat or Sentinel. Okay, simply choose your image and then filter the image collection. And there's a lot of way for filtering. In the previous class, we tried to discuss a lot of way for filtering. Okay, just choose and filter the image collection. Second step done. After that, it is a supervised machine learning method. So that's why you have to collect some training point. Which feature you want to classify? Just simply take this training point. Suppose I want to classify the cropland. So just I simply take the training point for the cropland. I want to classify the water body. I take the training point for the water body. I want to classify the build-up area. I simply take the training point for the build-up area. Okay. So which class you want to classify? Just simply take the training point. And now we can take the training point two way. If you want, you can take the training point directly. You can simply go to the field and take the training point, mainly GPS location, a specific coordinate you can take. Or if you want, you can take the training point from the satellite images. Suppose I want to add the satellite images, and from these satellite images, I take the training point. This is the water body, this is the vegetation, this is the build-up area. Okay. Or if you want, you can simply go to the field and take the GPS location. So this GPS location, we can simply import it in Google Earth Engine platform as a CSV file. Okay, a specific longitude and latitude for a specific feature. Okay, and then also take the training point as use this training point. So there are the two way for collecting the training point. Okay, so mainly when you want to make the classification for a specific crop, suppose I want to classify the rice, jute, or sugarcane, or then you must be including the ground truth data. Okay, otherwise we did not get the proper result. So it mainly need when you want to make the crop classification. Suppose different crop classification you want to classify it. So you can simply go to the field and then take the training point for different crops. Okay, then import in Google Earth Engine platform and use it as a training point. Okay, so this is the process for the training point, or we can simply take the training point from the satellite images. After that, we need to merge all of those training point together. Okay, and store it in a variable. Okay, suppose I take the training point for the build-up area, vegetation, barren land, settlement, all of those training point, I just merge and store it in a one variable. Okay, so after that, I need to create the training data set. Okay, so now how I can create this training data set? So basically, this training data set has a prediction band. In this time, I create a list, and in this list, I store it different band. Okay, so red band, green band, near infrared band, short wave infrared band. Okay, so this type of band I want to store it in a variable. Which training point I used for the different feature, I just extract the pixel value from this feature. Okay, so all of those pixel value I extract, and this is my data set. Okay, suppose I extract the all of those data set. Okay, so it's my training data set. Okay, when I show you the practically, then you can easily understand about that. So I need to create the training data set. Basically, this training data set is that pixel value, all of my prediction bands. Okay, after that, this data set I need to divide into two ways. So some data set I use for train my model, and some data set I use for test my model. So different time we are using here the ratio about that 70% data I use for train my model, and 30% data for use for check the validation, or 80% data for train my model, and 20% data for check the validation. Okay, so different time we are using the different ratio and train our model using the train set, and check our model validation using the test set. Okay, 80% or 20%, 70% or 30%. Okay, it's different. As well as after that, we need to create the classifier. Okay, suppose in this time we are using here the different types of classifier. If you want, you can use here the support vector machine or random forest. You can take the classifier, create the classifier. And Google Earth Engine platform, this classifier is already built in. Okay, it's a built-in function. So that's why you can simply call the classifier easily. Okay, after that, I simply call this classifier. This classifier I need to run with my trained dataset. Suppose I already create the dataset 80% dataset and 20% dataset. This 80% dataset I train with my classifier. Okay, after that I classify the image and display the result about the land use land cover classification. And then we have also used the 20% data and make the confusion matrix table for accuracy assessment, and then calculate the area for each classes. Okay, so let's go in this time. I try to show you the practically step by step, then it also better. All of those steps we can simply follow and then make the land use land cover classification map for any region. Okay, so let's go. So for that, I simply open my code editor. And first of all, I just simply open my study, I simply import my study area. Suppose Dhaka city, I simply import the Dhaka city region. Okay, so I import my area of interest and give this variable name such as ROI. You can use any name, put the name ROI. Okay, so now display the layer of my shapefile. So use at the map.art layer, and also need to focus the center of this shapefile with ROI. Suppose zoom level is the 10 and click to the run. So now it visualize my study area. So this is my study area. So for this study area, I need to create the land use land cover classification map. Okay, so this is my first step is done. Okay, select ROI or region of interest. After that, second step is that choose and filtering image collection. In this time, if you want, you can use here the Lancet, or if you want, you can use here the Sentinel. All of those images, same process. Okay, when you want to make the land use land cover classification map. So in this time, I simply go to my data set, browse data catalog, and I want to use here the Lancet imagery. So click on the Lancet. Okay, you can get the Lancet imagery look like that. You can see. Suppose I want to use the Lancet 8 imagery. So simply click on here. As well as also you can see that I want to use a surface reflectance imagery, mainly land use land cover classification map. We are using at the surface reflectance satellite imagery. So simply click on here. So here I can get this image collection between this time period. So first of all, I simply import the image collection. Simply copy and paste in here. And then give a variable name. Suppose I put the L8. Okay. So this is my image collection I imported. I choose this image collection. So now this image collection, I need to filter. Okay. So we can filter the image collection different way. If you want, you can take only for the single date image or single time period image. Or if you want, you can make the median composite. Okay. If you want, you can filter the image properties less than 1%. Okay. So a lot of way we try to, we already discussed about the filtering. So in this time I filter such as this way. I take a variable. Suppose like this L8, I just use here the filter bounds function with my region of interest. After that, I simply put here this filter. Suppose filter date function and put the space, suppose year of 2020. 1st January from year of 2020, December 31. And from this time period, I choose only for those images, which image will be not more than 1% cloud cover. So just put here this cloud cover less than 1. In this time, if you want to check how many images is available for your region, we can easily find out all of those images for my study area. We can check the result about that. You can see here I can find out total 5 images. In this time, if you want to work for the single time period image, we can get the all of the single time period image. You can see the year of 2020, 11th February. Okay, where we can get the 26th January. So when you want to work for the single class image, just simply use copy this ID and then simply display the image. We already discussed about that. In this time, I create the median composite. So for that, I simply use here the median and then simply clip with my shape file. Is that RY? Okay. So in this time, it will create the median composite. I want to display the result on my map. So for that, use here the map dot add layer function and call the image. Click to the run. So now it will be added a image. Okay, so I add the band visualization from here. So I added the band, suppose red band, then green band, and also blue band, custom 98%, and then apply. So now it added this visualization about this map, as well as also import that. Okay, and you can see when I import that, it will be added a visualization image visual parameter this variable. This variable I simply copy and then paste after the object name. Okay, I put the layer name such as image. Click to the run. So now I get my image. Okay, so in this time you can see our second step is done. Okay, so I choose the Landsat image and filter the image collection according to my choice. So in this time, from this satellite images, I just need to collect some training point such as water body, build up area, as well as also barren land, vegetation. Okay, so this type of class, which class you want to classify, just simply take the training point. We can training different way. You can simply go to the field and also import the CSV file format. Okay, and also take the training point, or if you want, you can use here the different types of spectral band combination. Okay, and take the training point from the satellite images. Okay, suppose you can see in this time here I use the band combination such as red, green, and blue. Okay, so it's called that natural color. What human can I see? Natural color or true color composite about that. So in this time, we can find out this result. You can see this is the water body, look like that. Also, this is the water body. We can get the settlement, look like that. And we can get the green pixel as a vegetation. Okay. But if you want, you can also use here the different band combination and you and identify the different feature easily. Such as I want to use this band combination, such as near infrared band. Also, then put here this red band and also put here this green band and custom 98% and apply. So now it will be showing the another band combination. And when I can get this result, this band combination mainly showing the water body as a black color. We can see all of this water body showing as a black color all time. When you want to use this band combination, all time this water body showing as a black color. Okay, as well as dense vegetation. Dense vegetation showing the result as a red color. You can see this type of bright red color. Okay, it's identify the dense vegetation region about that. Okay, you can see this is the water body. Okay, black color water body. Okay, so mainly when I use this band combination near infrared red and green, then I easily find out the water body from the satellite images as a black color. Okay, and dense vegetation is showing as a this type of color. Okay, bright red color. Okay, I can easily find out, as well as also another band combination such as I simply put at the short wave infrared 1, then put at the near infrared and put at the blue color, blue band, then apply. So mainly when I use this band combination, then we can get the result. You can see look like that. So mainly this band combination useful for identify the barren land. So in this time we can get the barren land look like that. You can see this type of color. Okay, this type of color identify the barren land. Okay, barren land. Okay, this type of color barren land. And it also benefit when you want to make the crop land. We are also using here this band combination 652. It also used for the take the training point. For that, when you want to take the training point for the crop land, we are also use this type of band combination. Okay, And we can use this band combination mainly analyzing the vegetation and also barren land. In this time we can easily find out the barren land. You can see this is the barren land, this type of color identify barren land. Okay, so different band combination when you want to use in here, then we can easily get the different feature from the satellite images. And from the satellite images we can easily take the training point from that. Okay, so let's go in this time. I take the training point. So first of all I take the training point, suppose water body. Okay, so for the water body training point, when you take any training point in Google Earth Engine platform, if you want you can use at this rectangle, or if you want also you can use here the point or marker. Okay, so in this time I use here the marker. So click on this marker, you can see a new geometry will be added in here. So simply click on here and put this name such as suppose water, and put here this feature collection. And property, I set the property name such as class. You can use any name, there is the no problem. I put the class, and this property name is the same for all of those feature. Suppose when I take this training point for the build up area, I use the same property. When I take the training point for the vegetation, I use the same property. Okay, and for the first water body I set the value as a 0. Okay, so all of those training point for water will be 0. Okay, so let's click on the OK. So now you can see it showing the water. So you can simply select, click on here, you can see it in the bold color now. So then you can simply take the training point. Suppose I take this training point from the water body. Okay, so I simply take this training point from this water body. Okay, so in this time I take the training point for the more than 30. So in this time how much training point I collect for this classification? Okay, so we try to use the more than 30 training point, but this training point will be increasing or decreasing after checking the accuracy. Okay, so if I did not get the better accuracy, then I also need to increasing my training point. Okay, so if there is a no limitation or fixed about the training point. If when I check the accuracy, if this accuracy is not good, then I also increasing the training point again. Okay, so in this time I take the 34 training point for the water body. So let's go, we take the another training point for that, suppose build up area. So simply click on here and put here this success name build up. You can use any name, there is no problem. And then feature collection property will be same name, class. In this time it will be 1. For build up area we can set the value for 1. Okay, so in this time I use here the another band combination such as put here this I use that natural color red, then put here the green, and also put here the blue. Okay, and apply. So now we can easily get the natural color band combination, and we can easily take this training point for the build up area. And when you mistake any training point, how we can easily remove that? Simply click on here and then click on this training point and delete that, then it will be removed. Okay, suppose I mistake this wrong place about this training point, how I can remove? Simply click on here and then delete, so then it will be removed. Okay, so again take the training point, simply click on here and then again training point, take the training point about that. So there is a lot of build up area, so just I simply take this training point from here. Okay, so then I take the training point such as for barren land. So simply click on here and put this barren land or fallow land, and then feature collection property will be class, set the value 01 and it will be 2. Okay, then okay. And in this time I use here this short wave infrared 1, then put here the near infrared, and then put here the blue, then apply. Okay, so now I can easily find out the barren land. You can see this type of barren land. You can easily find out this type of color. I select the barren land and take this training point from here. And in this time barren land, we can also this type of land, you can see this type of land, it's also wetland. We can also consider about that. If suppose you want to also mention about the classified the wetland, so then you can simply take the training point from here and also make the training point, make the class for the wetland. So in this time I also both of class at the same, so I take this not different about that, so that's I also take this wetland also as a barren land classes. I added that. Okay, so in this time I take the training point for the vegetation. So select on the new layer and click on here, and then put this name such as vegetation. Feature collection property name will be same such as class, and set the value for free. Okay, so you can see it will be start from 0, then 1, then 2, and then 3. So in this time I take the training point from the vegetation. So simply click on here. So in this time, all of those agricultural land or forest or tree, all of those things I want to consider as a vegetation, not separate about that. Okay, so let's go about that. So in this time I take this training from the vegetation. Okay, suppose in this time from this salary images I just classified the water, build up area, barren land, and vegetation. So I take the training point, all of those classes, and also it added with my code editor. You can see the water, build up area, barren land, and vegetation. Okay, so now I move to the third step, sorry, fourth step. Merge all of those training point. We need to merge all of those training point and store it in a variable. Okay, so for that, what can I do? Just simply take a variable. Suppose I put the variable name is that samples. You can use any variable name. In this variable, I stored all of those training points, such as water, it merge with build up. It also merge with parallel, and then also merge with vegetation. Okay, so in this time, what happened? I just simply merge all of those training point and store it in this variable. So now print that and check about the result. Simply use that the print function, and then simply call the samples and click the run. So now we can easily find out all of those pre-categorized data. Okay, so this is our data, all of those training point data. Okay, you can see here I can find out total 147 training point for all of those classes. Okay, you can see all of those data set already pre-categorized. Pre-categorized means that you can see, suppose 0 training point. Okay, so this training point, what's the class? If you want to check it, simply click on here and click on the properties. You can check that this is the class 0. Class 0 means that this training point I used for take the training point of water body. Okay, so all of those training data set already pre-categorized. You can see suppose 51. You can check about the data set. This for the class 1. Okay, so this training point I use for take the training point for build up area. Okay, because I put the value for the build up area is the 1. You can see the build up value is the 1. So all of those training point is already pre-categorized. You can see. Suppose this training point you can see +1. Okay. So all of those training point already pre-categorized. So in this time, from all of those training point, I want to extract the band pixel value. Okay. All of the training point, from that I just extract the band pixel value. Okay. So it's called my data set. So let's go about that. Which band I want to use, or which input properties I need to use in here. So for that, I simply make a list all of those band, which band pixel value I want to extract from all of those point. So let's go. So I make the list about the prediction bands which I want to use in here. So put here the bands. I take the variable bands. You can use any variable name, and then put here the band name such as SR. Suppose you also check all of those band information from here. You can see the bands SRB1, SRB2, total 7 band we can find out in here. So in this time I simply take all of those band. So SRB1, put here that SRB2, SRB3, put here SRB4, put here SRB5, put here SRB6, and also put here the SRB7, short wave infrared 2. Okay, so I in this time, so this is my band. Okay, so in this time I create the training data set. Training data set mainly all of those training points. Suppose this training point, for this training point I extract all of those band pixel value. Okay, all of those training points. Suppose this point I extract all of those band value. Here I can total 147 training point. So all of those training, from all of those training point I extract all of those band pixel value. Okay, so how I can extract all of those band pixel value? So let's go, and it's called the training data set. Training data set. So let's go about that. For training data set, first of all take a variable, suppose training, and in this variable, first of all, which image I want to use in this time. So this is my image. You can see I already create the image in here. So this is my image. Okay, from this image I just extract all of those pixel value, all of those band pixel value for specific all of those training point. Okay, so use here the select function and call this variable name bands and paste here in this time. So this is my image. Okay, from this image I select all of those band. Okay, is stored in this variable, and now I want to extract the pixel value. So for that I use a function sample regions. Okay, sample regions is a function when you want to extract the pixel value from any collection. Okay, so in this time all of my training point as a collection. So let's go about that. So in this time I make a dictionary. First argument is the collection. I also make the curly bracket end in here and put all of those things one by one. So first of all, collection. Collection is that your sample. Okay, all of those training point. All of those training point already I merge and store it in this variable. Okay, simply copy that and paste here. Okay, then properties. In this time, properties, for all of those training point, we are using here the same property. What our property name? Property name is the class. Okay, same property we are using in here. So in this time I simply call the properties and put here these properties. Then scale is that 30 meter resolution for that Landsat imagery, and it's not, I simply remove that. So just simply print the training. So now we can get the training data set. So click to the run. So here I can get, you can see for all of this individual training point, we can get the total all of this band pixel value about that. Okay, so what is the SRB1, all of this people you can get in here. So individual pixel, we can get this result look like that. Okay. So in this time, so this is our training data set. Okay. So this training data set stored it in this variable, stored it all of those training data set. This data set I need to divide into two way. Suppose 80 or 70% data I use for train my model, and suppose and 30% data used for my check the validation about the model. So we can separate look like that. So in this time, suppose I need to separate the data. So this training data set, from this training data set, suppose I use the 80% data for train my model, and 20% data for test my model. Okay. And I select the 80% data and 20% data randomly. Okay. So in this time, this training data set, I just from that 80% data for train my model and 20% data for test my model. I separate the data and it will be randomly. Okay. So in this time, I need to create a randomly distribution. So for that, I need to use a function, random column function. So for that, I simply take a variable, suppose data set, and I simply call this full data set. This full data set I want to take as a randomly. So put here the random column function. Okay. So now it this data set will be work as a randomly and stored it in this variable. Okay, data set. So now this data set I separate the 80% data and 20% data randomly. So let's go. So for that, I take a variable. Suppose I take the 80%. This is my train data set. So for that, take a variable. Suppose train set. Okay. So I simply call the data set and filter this data set. Earth engine filter less than random 0.8. Okay. And then also take the data for test set. So take the another variable such as test set. So I call this data set and filter this data set, Earth engine filter. In this time, use at the less than. In this time, I put here this greater than, greater than or equals randomly random 0.8. Okay. So now I take the 20% data from here. So just I simply separate the data set, train set and test set. Okay. So this train set I use for train my model, and this test set I use for check my validation about this model. So in this time, I need to create the model. Okay. Model means that built-in function already available in here. Such as if you want to click on here we can find out the lot of model. I simply search here the classifier. So here you can find out the model about that. You can see the different types of model such as random forest. Also you can see classification trees, minimum distance, support vector machine. Okay. So in this time, all of this algorithm has already lot of significance in the machine learning and a lot of equation, lot of analysis about that. But in this time, Google Earth Engine provide you the ready-made or built-in function about the random forest, classification trees, or minimum distance, support vector machine. So that's why we are not using any types of equation, any types of algorithm. Just we can simply copy the function because it's a built-in function. Just I simply copy about this function, and then in this time I create the model. Okay, so create the model. So take a variable. I put the variable name, suppose classifier. You can use any variable name, and then paste my model. In this time I use here the random forest algorithm. Okay, so EE classifier random forest, I put in here this algorithm. Okay, So I use this algorithm and train my data set, this data set. Okay, so in this time I simply call my algorithm. Okay, after that I simply train. So use at the train function, I train my 80% data. Okay, so I put all of those argument one by one. You can see, just simply make a dictionary. So curly bracket start as well also curly bracket end. Okay, so in this time I use here this feature. Okay, so mainly feature is that 80% data. Okay, so 80% data. So I call this train set, simply copy and paste here. Okay, then class property. So class property, we already put the class property name. You can see here, property name will be class. We already defined about that. Just I simply put here this class. In the meantime, you can see when I put the class property, I did not use any square bracket before start and end part. But when I fill up the argument for the class properties, you can see class properties, then I put here this square bracket. In this time, you can see the properties. So it is a plural form. So that's why it is a work as the list. Okay, so same. So in this time, so that's why I simply use here this square bracket. But in this time, it's showing as a property only for the class property single form. So that's why I simply use here this without did not put the square bracket. Okay, then input properties, I simply put here this. We already defined all of those band. You can see as the input properties and store it in this variable. Okay, so simply copy that. Okay, and then paste in here. Okay, in this time you can see properties, but I did not use here the square bracket because this variable already, you can see I already defined the square bracket in here. Okay, square bracket define and then make the list. Okay, then store it in this variable. So that's why in this time I don't use here the square bracket again. So in this time we don't need, simply remove that. Yeah. So this is my model. I created this model. Okay, so this is my model, and now this model I use and then classify the image. Okay, so after that we check the accuracy about this model. Okay, so in this time, before that, anyone any question about that full code, you can ask me. Anyone any question? Okay, anyone any question or any doubt?
Sir, in
Yeah,
command.
go on a message inbox.
Okay, I
So
check
it
the.
doubt.
Okay, yeah, please. Yes. Okay, lot of question. Yeah. Okay, so I check one by one. I take the answer. Okay, so first of all, you take the training point as a collection of the polygon. Okay, what should you do? Just simple process. You can see. So first of all, in this time I take the training point as a point. So that's why I use here the marker. But when you want to use here this, simply draw the. Suppose I take the new layer, and then I simply click on here. Okay. Okay. Now I take the geometry. Suppose I take the training point for that for the vegetation other thing. Simply same approach. Simply put the name. Suppose I put the name for that. Suppose road. You can use any name. Then put here this. Suppose feature collection. Then property. Same. All of those things will be same. Suppose set the value for 5 and then okay. Okay. Then what can you do? Just you can simply zoom and draw your polygon. Okay, so now it will be work. It will extract the pixel value from here. Okay, so suppose in this time it will extract the pixel value from this polygon. Okay, so this is the process for taking the training point as the polygon. Okay, so I remove that. In this time I will not use that. But when you want to use this technique, just simply same approach. Just not select the marker. Simply select this rectangle and then take the training point. Okay, and also put here the input this property or name, then also feature extract the all of those things will be same approach. Okay, so this is the approach about that. And next question I check. Okay, for build up area, can we further classify according the height or density of building? Okay, so it's also a good question. So it's also possible to build up area. We can also classify the height or density of building, but then we have also need to import the DEM data. Okay, so DEM data we also need to consider in here, and then we also this DEM data we can mark for that build up area. Then we can easily do that. for that consider from this classification. We also make the height or about the building or build up area. Okay, then okay. So in the case of forest classification, is it possible to have many subclasses, savanna, wetland? Yeah, of course. Yeah, of course it's possible to classify the savanna, wetland, or dense forest or woody land. Okay, just you have to take the training point. Okay, so use the different types of band combination or take the training point from the satellite images. Or if you have the ground truth data, then simply import the ground truth data. Okay, and basically okay specific one to highlight the kinds of subclasses. Yeah, so I already discussed about the wetland, okay, or barren land, how you can easily go to the barren land, as well as you also try to find the link in here such as band combination. For band combination of Lancet 8, just simply go to this link. Okay, so in this link they are also discussed about that different types of band combination, which feature we can easily find out from here. Okay, so we also try to read about that. You can see, okay, this is the band combination natural color, and when you use the band combination, what types of feature we can find out easily. Also you can see the band combination about that, this type of color infrared. When you use the band combination, what type of feature we can find out in the satellite images. Okay, so there's a lot of band combination we are using, and then find out. You can see mainly it's useful for the agricultural land. When you use the band combination look like that, we can easily find out the agricultural land or also get the barren land about that magenta color. Okay, so this type of also you can see geological feature. Okay, so this type of bathymetric feature. Okay, panchrometric feature. Okay, so this type of band combination, and there are the more lot of band combination about that. Here I mentioned some. So you also try to find out the different band combination. Okay, and which band combination provide you which information. Then we can easily use that in Google Earth Engine platform, and you can easily find out the feature from your satellite images. Yeah. Okay. So next. Okay. So for
Yes, sir.
forest area, how it works. Okay, forest area. Okay, so if you want, you can also classify the forest. Yeah, you can also take this forest. Okay, so mainly forest, when you want to use the band combination, we can get the forest mainly showing that as a deep green color. Okay, suppose in this time you can check the result about that. Mm, just a minute. Okay, so in this time we can see when you classify the cropland. So cropland we can get this type of structure such as a rectangle structure. Okay, rectangle structure. This green pixel value work as a rectangle structure. But when you want to do for the forest or vegetation, it will be not showing this type of rectangle structure. Okay, it is it's showing the distributed, not unrandomly. Okay, so but agricultural land we can get the structure, this type of rectangle structure, this type of we can easily find out. Okay, suppose you can see all of those agricultural land showing as a structure, a square or rectangle structure we can get. So from that we can identify this is the cropland. But vegetation distributed randomly, so here we can get the some and it's not maintain the structure about that pixel value. But cropland or agriculture, it maintain the structure, it can be a square or also rectangle about this. From that we can easily find out that this is the agriculture land. Okay, a lot of technique for identify the feature from the satellite images. Yeah. Yes, also context the main government define the land 5 meter. Yeah, canopy covered the less than 10%, and trees able to reach this threshold in soil. Yes, yeah. So after that, how we can compute the assemble of models? I mean, raw together RF, VRT, or it's like okay, GLM, VRT. Okay, so okay, so in this time, uh, if this algorithm is available in Google Earth Engine platform, then you can easily run that together at the same time. If it is not available, then we not about that. So basically, in Google Earth Engine platform, this type of algorithm you can find out. You can see only for this classifier, such as decision tree. Also, you can see support vector machine, minimum distance. classification trees. Okay, so this type of a built-in classifier we can use in here, and also make the classifier, and also create the model, and also check the accuracy about that. Okay, so now please, anyone any question?
Question.
Yeah,
Hello.
please. Yeah,
Hello.
please.
I
Yes,
have
sir.
a
Please,
question.
sir, could you
Like,
please come back?
hello.
Yeah, please.
I have a question. Like, how we can import polygons or point data if
Yeah.
we already having ground truth, and if we want to use those ground truth for crop classification,
Okay.
then how we can use that?
Okay, just a minute. I simply send a video about that. You can simply check it and also import it from the point or polygon. Just this point or polygon, we just simply import it using the specific coordinate or lat long, as well as can also import it. Just a minute. I simply send you. You know.
Sir, a question.
Yeah, please. You can ask. Yeah.
The workflow on the training data set was not well understood for me.
Okay, training data set. Okay, I also can explain about that. Just a minute.
And one more question, like if we want to change the classifier, suppose here you have used random forest.
Yeah.
Suppose you want to use SVM or any other classifier. So
Yeah.
what would be the procedure? Like only we
Oh,
have to
yeah.
import those.
Just change the classifier name. You can see. Just
Okay.
change the classifier name in here. In this time, suppose I have the classifier name, just simply change it. Okay, then it will work. Okay, and all of those things will be same. Just change
Okay.
the classifier from here.
Suppose here if you do SVM, then
Same approach. We can simply call this SVM. You can see support vector machine algorithm, and you have also need to know about that which algorithm is better for your classification. Okay, so this is the main question about that. Suppose support vector machine is better for your classification or not. First of all, you have to check about that. Okay, then you can make the decision which classifier you need to use. Okay,
we
so
can also
mainly,
do in
yeah.
a way like we use all the classification and through results we can see.
Okay, so basically different classification. Suppose when you want to make that only for the two class, such as you need to make the classification for that forest and deforestation region, then support vector machine is work well. Okay,
Okay.
when you want to make that classification for the lot of classes such as build up area, vegetation, or barren land or settlement, then random forest is work well,
Okay.
as well as classification and regression trees is all classification and regression trees also work for that regression as well as also classification, both of things. And it also work for that when you want to classify the lot of classes. Okay, then more than two classes, then it also work well for the classification trees.
Okay.
Okay, as well as also dictionary minimum distance. Okay, and all of those classifier has a lot of statistical background. Okay, suppose max node, what is the max node, what is the decision tree. So if you want understand all of those things, then you can easily idea which algorithm or which model you have to use, then you can easily get the idea and easily use it. Okay,
Okay, thank you.
okay. So anyone question about that?
So I would like to add that
Oh my god, you
the
neural,
machine
yeah.
learning
So
algorithm
okay,
depend
so deep
on
learning is
sovereignty.
not possible to use freely in Google Earth Engine platform. Okay, so it's not possible to use the deep learning models such as CNN, convolution neural network, or alien neural network. So this type of is not possible to use in here. Okay, without free. Okay, for that we have to buy the some process. We need to buy from this. When you want to apply the Google Earth Engine platform with the deep learning, we have to buy something from here. Okay, paid available you need to use in here, otherwise it's not possible. But in the meantime, we are also for this convolution network or CNN, we have to have the TensorFlow. Okay, so it also better. We can use the freely using the Python, TensorFlow, and Crush for this type of AN or CNN classification using the deep learning. It also work for the freely, using the TensorFlow Python. Okay, so that's why in this time we will not talk about the deep learning because it's the paidable. But if you are interested to learn this deep learning, then I suggest you can just follow the Python, TensorFlow, and Cross, and join this, learn about that, how we can easily do that using the deep learning. Okay, and we have also the another online training program about the deep learning for the different types of models such as CNN, ANN, how we can easily use and then also make the classification. Okay, so if you want to interest, then you will join our deep learning online training program and also learn all of those things from the beginners to advanced level. Yeah. Okay, so I also, okay, you can get all of the inform from here. There is no problem. But in this time, we're not work about the AN or CNN for this deep learning. Yeah. So any question, please?
Yes, I have a question.
Yeah, please.
Yeah, please. I want to know if, based on this classification, is it possible to make projection for the future?
Future projection. Okay. So any types of prediction, when you want to do in Google Earth Engine platform, you have to go to the paid version. Otherwise, it's not possible. Okay,
The
it's
pay
possible.
option.
Yeah, we can take this algorithm, prediction algorithm from the Google Earth Engine platform. We need to buy. Okay, then use
Okay.
this algorithm and make the prediction for the land use, land cover classification or other things. We can use it about that. Okay, but it is also possible, but we have to buy that. Okay, so that's why in Google Earth Engine platform we have to use the deep learning or about Python. So that's why Python is also benefit for that. Okay, Python, TensorFlow, or Cross we can easily use and make the prediction also about that. Okay, how to buy it? Okay, it's very easily. You can simply search on the Google. I simply search, suppose Google Earth Engine deep learning. You can get the some price about that and also get the some suggestion about the deep learning. You can also try to show about that. Okay, so you can see warning about that. You have to must cost about this deep learning AI platform price. You want to check how what is the price, all of those things. Cloud storage, you need to buy all of those things one by one, and you can simply make the payment using their MasterCard or Visa card. Then they can also provide all of those things, all of those code. You can easily find out from here. And you can also contact in here their chat box. You can see, simply click on here and also directly message them and also get the help for create your algorithm which you want to need. Okay, all of those things you can get from here and use it. Okay, so for this, when you want to make the prediction or other things from here, you can easily get this about this result. Okay, and you can also estimate, calculate how much dollar you want to need to pay for that.
Okay.
Then put all of them. Simply go to this link, and you can easily get all of those things from. And also you can contact about live chat with that, and also get the information, all of those things. Yeah,
Send the link.
yeah, please.
Send the link.
Okay.
Send the link, please.
Okay, just a minute. I send you the link. Okay, just you can chat with this, then you can easily get all of this information or kind information you can easily get from.
Okay. Thank you very much.
Yeah.
I have 3 questions.
Yeah, please.
My first question is the limitation of taking points is 5,000. So
Yes.
when we have a big area, so how can we increase the points there?
Okay, so for that, because in this time it has also some limitation about that. Suppose you take the rectangle and make the training point from here, then it will be just stuck the when it will be stuck the 5,000 limitation cross that, then it will be not work. Okay, so that's why it also better we are using here the marker. Okay, without the rectangle, we just use here the marker and take the training point. Okay, and when you take the rectangle, then it stands to cross the limit for the 5,000 element. So that's why its solution is that we take the training point as a marker. Okay.
Okay, but can we do it as a tile? then join it later?
Yeah, so in this time, so you can take the training point. You can take the use the a small area about that rectangle. Then it also possible to get the training point. Actually, this is the limitation about the Google Earth Engine platform. When it will be across the limit, then it will be not work for that. It did not able to extract the pixel value when it will cross the limit about the 5,000 element. Okay, so that's why I take the very small rectangle and extract the information from here.
My second question is that the randomize, the function you used, can we use it before the training data set? Like you have got the points, and we, after getting the points, like ground control points, we separate the points this before training. Can we do that?
So it also
Like
possible. So in this time you can say separate the data, but if you want, you can also take the all of those data. Suppose simply call this data set full data set. Okay, this 100% data set and train your model. Okay, so it also possible to use that for that. So it also possible or you can train your model with the full data set. Okay, it also possible to that.
Okay, my third question is that the random forest, the number of trees, depending
It
on the
also need.
number of trees.
So I also
So
so in this time for the random forest number of trees, so mainly we are using here the 100 to 150. Okay, so this number of trees mainly it is that number of trees. Okay, so I also try to discuss later because I did not put the number of trees because I get the wrong, and then I explained how we can easily fix the number of trees about that. Okay.
okay, that show me, because different number of trees will give the different accuracies.
Yes.
So okay, thank you.
Okay, thank you. Because the number of trees is that compulsory, you must be used, otherwise when I run the code it will be not work or not displaying the image, classified image. Okay, so any question or anything else about that?
My question was about I do not understand well the workflow on the training data set.
Okay, I can explain just okay. So you can see these are data set. So these are data set training, so it stored the full data. Okay, and this full data I need to take randomly 80% and 20% about that. So that's why I simply use here the random column. Okay, so this random column mainly this function used for the data set randomly distributed. Okay, and store it in this variable data set. Okay, so now I can simply take a variable train set and call this full data set. Okay, from this full data set I just filter this data set. I filter Earth Engine filter less than randomly 0.8. Okay, and after that you can see here I use here this call the data set and filter it randomly Earth Engine filter greater than or equals randomly 0.8. So in this time it takes the data from the full data set. It less than 0.8 means that 80% data set is stored in here, in or greater than or equals randomly 0.8, it is stored the 20% data in here. So we can simply separate using the less than or greater than or equals in here randomly about the data set, and then store it in this variable. Okay, so now I just simply call this train set data and just add with my model. Okay, so after that I create this model, and now this model I just add with my image. Okay, which I already create the image. So when I add with my image, then it will be classified our image. Okay, And then after that, we are check the accuracy using the same model. We are using here the same model and check the accuracy about this using the test set. Okay, so let's go about that. We check about the display of the image. So create the classified image. So for the create the classified image, what can I do? Just I simply call my take a variable, suppose classified. You can use any variable name, and then I call my image, which image I want to classify. In this time, I want to classify this image. So simply copy that and paste. Okay, and then this image has also some specific
Okay.
band which I already use in here. So simply copy this variable. Okay, so now you can say I simply call my image and also select my band which I use. And now I just simply use a function, classify function. Okay, so mainly this classify function is connecting the model or connecting the classifier which I create this model. Okay, so in this time, all of those things stored in this variable. Simply copy that and paste here. Okay, so in this time, this is my image. I simply call my image and also select all of those band which I use in here, and then use here the classify function and use here the classifier. Mainly classifier, it stored my model, random forest model. Okay, so now in this time, when I click to the run, we can get an error. You can see. So I simply use here the map.add layer and call the classified. Okay. Okay. In this time, you can see the result. We can make the problem in here. So we can must put here the number of trees. Okay. In this time, what's the value? What is the accurate value for this number of trees? There is the no constant value about that. Okay. If you want to check the argument about that, you can see the number of trees. The number of decision trees to create. Okay, so in this time we need to put here this integer number. Okay, so and it's represented the number of decision trees to create. So there is the no limitation about that, how much decision trees you put in here. So it's depend on your algorithm, it's depend on your accuracy. Okay, so in this time when I put here the 100 and check the accuracy, we can get the another accuracy. When I put here the 150, I check the accuracy, I can take the another accuracy. Okay, but in this time I need to use this decision trees value which I can get the better accuracy. Suppose I use here the 100, then I can get the accuracy is the 82. But when I put the decision tree 150, I can get the 90% accuracy. Okay, so then I use here the 150 as a decision trees. Okay, so in this time I check it. Suppose I put here this 100, first of all 100, and then check about this result accuracy. Then if I did not get the proper accuracy, then I also increasing this decision tree number. Okay, so then check about that. Okay, it classified in this time, it will be work, you can see, but it not showing the result. It's showing that this type of work you can get. So in this time we need to add here the color. Just I simply remove that and add the color.